Welcome everyone to this new video about geometric sequences in series. So a geometric sequence is a sequence that is obtained by multiplying the same value each time to the previous term of the sequence. If we can recall what I told you in the previous video about arithmetic sequences, you will remember that a sequence is basically an ordered list of numbers. There is a recursive formula to define geometric sequences. So the recursive formula of geometric sequence would be that un is equal to the previous term un minus 1 times r, where r is a common ratio, the constant, by which every term in the sequence is multiplied. We can also define a geometric sequence using a general formula, which would be un is equal to u1, or the first number of the sequence, times r to the n minus 1. So these two formulas are the backbone of geometric sequences. Now I will give you more concrete examples to give you an idea of what they look like. So an example of a geometric sequence would be 5, 15, 45, 135, and so on. And we can see that the first term of the sequence is 5, right? And that each term is multiplied by 3 to get the following term, right? So 5 multiplied by 3 would give us 15, 15 multiplied by 3 would give us 45, which perfectly aligns with the recursive formula I told you about earlier. So if we were to write it, any term in the sequence will be equal to the previous term in the sequence times 3. Or if we were to use a general formula, we would find that any term in the sequence would be equal to 5 times 3 to the power of n minus 1. Now, in this example, the common ratio is greater than 1. So basically, the sequence will always be increasing. But it does not always have to be the case. The common ratio can also be negative. So when the common ratio will be negative, the sequence will go from a positive number to a negative number, or vice versa. We'll go from a negative number to positive numbers, to a negative number to positive numbers. So basically, if this was negative 3, so times negative 3 rather than 3, we would get that it's equal to 5 times negative 15. Negative 15, 45, and negative 135, and so on, right? So that will be also here again, negative 3. But I said before, it can be also lesser than 1 and greater than 0. And when that is the case, the sequence will be decreasing rather than increasing. For instance, when the ratio is equal to 1/2, the sequence will decrease. So we can sum geometric sequences, right? So to notify that we are summing geometric sequences, overly known as geometric series, we use a sigma sign, right? And so the sigma sign of u1 times r to n minus 1 from r is equal to 1 to n. When n is finite, this can actually be written as u1 times 1 minus r to the power of n divided by 1 minus r. So the sum basically of this geometric series, geometric sequence, when the geometric sequence is finite, so when it has an n numbers, it doesn't go infinitely, will be equal to this. So you can wonder, how did people come up with this? Let's say we have a sequence S is equal to A, AR, AR to the second, AR to the third, and so on, until we've reached the final number, AR to the n minus 1. So S times R will be equal to AR squared, AR to the third, AR to the fourth, and so on, until we find ar to the negative to the power of n minus 1 and ar to the n, right? Because ar to the n minus 1 times r will be equal to ar to the n. Now we have these two sequences, right? And let's subtract them. Let's subtract s times r from s. So s minus s times r would be equal to, well, ar and ar will cancel out, right? Ar squared and ar squared will cancel out. Ar to the cube will cancel out, and so on, until we get to ar to the n minus 1 and ar to the n minus 1. So we left out with a minus ar to the n. We can rewrite this formula as s to the 1 minus r is equal to a times 1 minus r to the n, or s is equal to a times 1 minus r to the 1 minus r. So that is how we got this formula, where a is the same thing as u1 and r is the same again. So I told you before that we had to be careful that the sequences had to be finite, because when it is infinite we cannot use this formula anymore. And unfortunately we will not go over it today, but maybe in another video. And that will be all from me today, and thank you for watching.